We now continue our work on using the substitution method. Recall what we need to do is to isolate a pronumeral in one of the equations. Then we are going to substitute its expression into the other equation. Examples. We are asked to solve the equations simultaneously. The first one here is x squared plus 3y equals minus 5 and y equals x minus 5. Now we can see there in that second equation there the y is already by itself. So we're going to replace the y in the other one with x minus 5. So we substitute equation 2 into equation 1. So where we see the y, we're going to replace with x minus 5. And we get then that x squared plus 3, and then in brackets, x minus 5 equals minus 5. Now we can see that x minus 5, of course, make sure it is in brackets. Okay, if it's not in brackets, then we're going to have problems expanding. Now we need to expand the brackets in that one. So we're going to have x squared, that's out by itself, but the 3 is multiplying by the brackets. That's why we get the plus 3x minus 15 on the right side equals minus 5. Now we have a quadratic here, and with a quadratic we like to get everything to one side and make it equal 0. So that x squared plus 3x, we're going to leave it there. The minus 15, okay, if you think about it, we need to bring that minus 5 over to join it. When it comes over, it becomes plus 5. So the minus 15 plus 5 is minus 10. And since we've moved that minus 5, okay, think about it, it's no longer there, we have equals 0. So now we have a quadratic equation, we need to solve that. So we need to factorize two brackets, x and x, numbers that multiply to give minus 10 and add to give plus 3. Need to think of those two numbers. Can you think of them? Certainly one of them will be a plus and one of them will be a minus, won't they? Well, the numbers are plus 5 and minus 2. So we factorize that left-hand side. It equals 0 there on the right. So then we have two mini equations. We have x plus 5 equals 0. So therefore x equals minus 5 for that part. Or the other solution, when x minus 2 is 0, solving that we get that x equals 2. Now when x equals minus 5, okay, there's one of our solutions. We need to substitute back into equation 2 there because that will tell us what y equals. So putting that in, we get that y equals minus 10. Our other solution for x, okay, x equals to 2. Again, we substitute that into that equation, and putting 2 there for x, we get that y equals minus 3. So our solution, okay, well that's our first pair. There's two pairs of solution. Our first pair there is minus 5 minus 10. The way we can write that is that x comma y in brackets, okay? So x and y equals minus 5 and minus 10. Have a think about that. Or our other answer was 2 and negative 3. Okay, and one of the reasons we like to write it like that because often these questions relate to questions on the number plane, alright, graphing curves and graphing straight lines and seeing where they intersect. Alright, so those 2 points, for example, would be a points of intersection if we were to graph those equations. Terrific. Our second example now, x squared plus 3y equals 12. That's equation 1. And equation 2, x minus 2y minus 1 equals 0. Well, we can see here we haven't got in either equation any of the pronumerals isolated. So if we concentrate on equation 2, if we try to get that x by itself, that's what we'll try to do. To do that, we'll need to move every other term to the other side. Alright, so that's what we're going to try to do because we need to isolate that x. So if we do that, rearranging 2, that's what we're doing. We're rearranging equation 2, getting the x by itself. Let's write the x by itself. The minus 2y minus 1 comes over and it changes signs. So it becomes positive 2y plus 1. So we'll call that new equation, equation 3. Now, once we've got that rearranged like that, we have x by itself. We can say that x is 2y plus 1. So into equation 1, where we see x, we're going to replace that with 2y plus 1. Alright, in this case x is being squared, so we'll write 2y plus 1 in brackets squared plus 3y equals 12. Okay, that 2y plus 1 is being squared. Of course, make sure it's in brackets. Okay, if you haven't got it in brackets, there will be problems. I'll guarantee it. So let's expand that. We get that 4y squared plus 4y plus 1. Okay, that's the perfect square expanded. Then we have plus 3y equals 12. Alright, remember that perfect square expansion? First term squared, twice the product, then the last term squared. Now let's collect like terms. Well, 4y squared, there's no other y squared, so we'll write that down. The 4y and the 3y, can write that as plus 7y. And the 1, we're going to bring the 12 over to join it. The 12, when it comes over, becomes minus 12. So 1 minus 12 is minus 11. And because we've moved the 12, we write equals 0. So now we have a quadratic equation there. Need to factorize that. We get y minus 1 multiplied by 4y plus 11, and that equals 0. Now, I factored that in one line. You may need to think, how do we really factorize that? If we can't do it in one line, that's okay. We do it in stages. So 4y squared, 4y over 4, okay? Because it's not just the singular y squared in front, it's 4y squared. And if you can remember, then we cross out that minus 11 and multiply it by 4, make it minus 44. So we're looking for two numbers then that times to give minus 44 and add to give 7. So those two numbers would be minus 4 and plus 11. Then in terms of that, we need to think which of those brackets highlighted would divide completely by 4. Okay, the first bracket or the second bracket? What do you think? Well, it's the first bracket, okay? 4 will go into each of those terms. And when you do that division, you get that y minus 1. You see that? Okay, that's how we arrived at y minus 1. The second bracket just remains as is. You don't need to change that at all. So that factorization method, of course, can be used if you can't do it all in one line. Okay, let's move on now. We're now solving y minus 1 equals 0. We get that y equals 1. Or, the other solution for y, when 4y plus 11 equals 0, we get that y equals minus 11 quarters. And we can write that as a mixed number, minus 2 3/4. Now, they are our solutions for y. We need to find x now. So we're going to take that solution and we're going to substitute it back into equation 3. The reason we chose equation 3 rather than the other two is because that x is by itself there, right? So once we put the y in, we'll get an answer straight away. And if we substitute that, the y equals 1 into that equation, we get that x equals 3. And then we take our other y value, minus 2 3/4. Again, we substitute that back into the equation. So we'll get that 2 times minus 2 3/4 plus 1. We get that x equals minus 4.5. So our solution, there's our first pair. Again, we'll write x, y, and we write that in that order, x followed by the y. So that will equal 3 and 1. Or our other solution is minus 4.5 and minus 2 3/4.